Next, we have Rohan Salvi, AI architect, Parallon, USA. Rohan Salvi is a conversational AI architect and developer specializing in intelligent voice and chatbot systems. With hands on experience across platforms like Dialogflow CX, Amazon Lex, and ChatGPT APIs, he has built scalable AI driven customer support solutions and voice user interfaces. Rohan holds a master's in information systems from the University of Maryland, Baltimore County, and is passionate about advancing human machine communication through NLP and deep learning technologies.
Hey, am I audible?
Yes, sir.
Thank you. So let me, yeah. So the topic would be federated and privacy preserving conversational AI. So first, coming to understanding what is a conversational AI. Conversational AI is technology that enables computers to understand, process, and respond to human language in natural, human-like conversations. Think of it as giving machines the ability to chat with us, just like we would chat with any other person, whether through speaking or typing. Some examples I would like to share of conversational AI are Siri, Google Assistant, then voice control TV remote, banking app chatbot, Amazon Alexa, and then one would be customer service chatbot. Coming to the components of conversational AI, first I would say is natural language understanding, which interprets the meaning and the intent behind your words. And then we come to at automatic speech recognition, which converts spoken words into text that computer can process. We have dialogue management, which keeps track of conversation context and flow. Then we have machine learning response prediction, which uses AI at the back end and determines appropriate responses. We have natural language generation, NLG, which creates almost human-like responses in natural language. So why conversational AI matters today? The technology has almost reached remarkable maturity with consumer adoption growing from 23% in 2020 to 75 in 2025, while business adoption is projected to reach 83% by 2025. And then over 68% of consumers have used a customer service chatbot at least once, and 51% prefer interacting with bots when they want immediate service. The appeal lies in its simplicity. Conversational AI removes learning curve typically associated with new technology. Instead of memorizing commands or navigating complex interfaces, user can simply talk or type naturally to get what they need. This gives access to technology and information, making digital services accessible to everyone, regardless of technical expertise. So, crisis facing conversational AI, security, privacy, and trust. So coming to the scale of the problem, by 2025, an estimated 67.9% of global population rely on internet-connected AI tools like ChatGPT for daily tasks. However, this explosive growth has occurred without adequate safeguards, creating unprecedented exposure risks that centralized AI architectures cannot adequately address. So coming to the problem statement, the widespread adoption of conversational AI has created a perfect storm of privacy violations, security vulnerabilities, regulatory compliance challenges, and user trust erosion due to centralized cloud architectures that concentrate massive amounts of sensitive personal data in single location, creating attractive targets for attackers and exposing users to unauthorized data collection and accidental recordings. Yeah, let's talk about the problems precisely. First comes pervasive privacy risks. So centralized cloud models, which are current and prevalent right now, they concentrate massive amounts of sensitive user data. 91% users experience unwanted recordings, often capturing private information. Sophisticated security threats. So new attacks vector like deepfake audio and inaudible commands bypass traditional security. High-profile breaches. ChatGPT call centers have already exposed millions of records. That crushing regulatory pressure. The EU Act is now in effect with the fines up to 35 million euros or 7% of global turnover. Compliance is complex and urgent, with key deadlines in 25 and 2026. Erosion of user trust. 65% of consumers fear cloud transcription exposes their private conversations. Lack of transparency and control is undermining confidence and slowing adoption. Yep. Uh, Coming to what is federated learning. Federated learning is a decentralized machine learning paradigm where multiple user or clients or call centers collaboratively train shared model without sharing the raw data. Instead of centralizing sensitive data, each client trains locally and sends only the model upgrades, that is the gradients and the weight deltas, to the central aggregator, that is a main server. Here is an example of how a federated learning server would work. And there are a few steps I would like to quickly glance over, where the server first gives tasks to the clients, which are mobile, which can be mobile devices, servers, or the sites, where each clients work on the task that is initialized on their individual level, and then they upload only the gradients or the weights to the server, updating the model, not the raw data. So key distinctions versus centralized learning. In standard ML, all data is gathered at server for training. In federated learning, data never leaves the client, only parameter updates are exchanged. FL handles heterogeneous data. Each call center has its own mix of languages, intents, and volumes. If ignored, local updates can diverge and degrade the shared model. Techniques like client clustering, regularization, and even small shared datasets can align learning and perceive accuracy. How it works, federated training loop. So local model training, multiple clients, or I would say devices such as smartphones, servers, or call centers train a shared model locally using their own private data. No data leaves their devices. Sending model updates. Instead of sharing their own raw data, each client sends only the learned updates from its training, such as its gradients or model weights, to a central server. These updates contain knowledge gained from local data but do not expose sensitive information. Aggregation at the server. The central server collects updates from all the clients, combines them to improve the global model. The privacy techniques like secure aggregation or differential privacy can be used here to protect the individual contributions. Distributing the improved model. The improved global model is then sent back or pushed down to from the server to each of the client device. And then the cycle repeats. Each time the model gets a little better, using new updates from all the participants that participants while keeping everyone's raw data safe and private. So why FL wins over voice and conversational AI? Privacy by its design, voice data contains the most intimate personal information. FL keeps audio recordings and transcriptions on local devices or servers. Only the model improvements or the gradients are shared, never the raw conversations. And it also meets GDPR data minimization and the EU Act requirements by its design. So coming to regulatory compliance, it makes it simple. High-risk voice system needs documented privacy controls. It also follows HIPAA. Healthcare and financial call centers cannot share sensitive transcription. transcripts. FL provides built-in compilers, no need for complex data sharing agreements. An audit trail shows the data never left the organizational boundaries. Collaborative learning without data sharing. So the uh, one example I would like to share here is we can have multiple call centers which can jointly train better models, and then each participant can benefit irrespective of their linguistic patterns and their edge cases. And collective intelligence can happen without any data exposure. Cross-silo architecture. Every call center, like we have discussed, has its own call recordings. A small copy of model learns from only those local calls. And then there is a crypto masking, uh, which is done before anything leaves the devices. The center scrambles its models, tweaks with a secret key. The tweaks look like random numbers to anyone else in the server. Central averaging. The central server receives the scrambled tweaks from all the centers. It adds them together. The new global model, the server sends this average model back to every center. Each center starts the next round a little smarter without sharing any raw calls. So when each client looks different, how do we keep learning on the track? Um, Data mix is different in real world scenario. So one center gets Spanish spelling calls, another gets an English tech calls. Updates pull the shared model in opposite directions. And then we have call volumes, which may vary in the central normal case scenario, where there is a big hubs, almost four times the normal hospitals or the servers, which receive more calls compared to a small clinic. And in that scenario, the bigger hub can dominate the learning. There is a possibility of slow and offline sites. Some centers have shaky VPN links, which sometimes have the training fails due to the longer wait times in those scenarios. So the key challenges and how do we fix them in FL? We have few methods like FedProx, which acts like a rubber band that stops any one client from straying too far from the global model. We have Scaffold, which sends tiny correction notes with each round, so each client don't wander off in different directions. We have client clustering or personalization, which groups similar clients. Clients here are referred to the mobile devices or individual servers, or which which uh, which have s- so act which similar which group similar clients, so the accents and the language stay sharp. And then asynchronous partial rounds, the server moves ahead after, let's say, 70% of client report, so slow links don't hold everyone up. Privacy and security stack. So we have a three-layer security masking that happens in federated learning. One is crypto masking, which is also called secure aggregation, differential privacy noise, and robust aggregation filters. Coming to crypto masking, what happens is each mobile device or each site scrambles its model, tweaks with secret key before sending them. The server only ever sees the sum, never any single client's update. Coming to differential privacy noise, after masking, every update gets a tiny dose of random noise. Even if someone stole the final model, still they couldn't reverse engineer what the one caller said or the what one user said. Coming to robust aggregation filters, the server checks incoming updates for weird or malicious patterns and then tosses the bad ones off. And white matters, which it blocks the hacked or the rogue clients from sneaking into the back doors of the main server or the garbage that would corrupt the shared model. So within the accuracy, so how much accuracy do we really lose when we add privacy? So here we are talking about the noise. Adding noise would make the data wouldn't make the data back go bad here. So we have a table here which shows three phases of noise, addition of noise. When we have no noise, the data shows that it is still 92% accurate. And even when we add 6 to 8% of noise, so this is a voice data when we add voice, when we add noise to a voice call, it still gives 90 to 91 percentage of accuracy. So the smaller the epsilon, more privacy. That's what we see. And then the medium still performs the best, the medium epsilon. Coming to key takeaways. So FL in FL, training local model and sharing the only gradients is what happens. Federated learning keeps the raw data between its clients and recording each within its clients. And then erect three privacy walls that we have: crypto masking, which is secure aggregation, which adds differential privacy noise as a second layer, and also filter out the weird poison updates, the robust aggregation. So, and then we come to use of drift fixing tricks like fed procs and scaffold, and asynchronous round keeps the training stable when data mixes and connection speed differ across the sites. Um, Coming to the conclusion of, yeah, this would be my conclusion. Just a second. Can you see the screen?
Yes, sir.
Hello?
Yes, sir. We can see the screen.
Yeah. So coming to the conclusion, the federated learning is not just a research experiment, it's a practical production-ready solution to the privacy trust and compliance crisis facing conversational AI. By moving from central data hoarding to decentralized privacy preserving collaboration, we can build voice assistants and chatbots that are smarter, safer, and ready to meet the world's toughest regulations. Thank you.
Thank you, Mr. Rohan Salvi, for your thought provoking talk. Your insights on federated and privacy preserving conversational AI shed light on the future of secure and intelligent human machine interaction. We greatly appreciate your contribution to ICCCNet 2025.